All right. So the next two tests today for H4. We're recording tests when people are absent and record. I recorded the other class too, so that way. Let's go ahead. And it's a lot easier. So like if you had to be absent for something, I can record for you if you asked me to. Cool. Okay. Okay. So anyway, comparison tests. We're gonna do two tests today. They're both different comparison tests. They have specific names. Okay. There's the direct comparison test. If you want to like look over that on your little blue sheet where that's located, and the limit comparison test. Those are the two we're going to do today. Now they're a little bit harder to think about. Okay, they're not as straightforward as what you've done. You actually have to think logically a little bit about that. So when you have a direct comparison test, so let's say that this A sub n is a series that's smaller than B sub n. So think about if I had a B sub n, what's something that's smaller? Okay, so this one would be smaller, right? It's something that's bigger. 1 over n squared. Do you agree with that? Because when the denominators are bigger, they actually make a smaller number, right? So what you want to try to do is find a summation going on that you could easily take one of the other rules that you've learned about. Well, this one right here, could you easily take the what? The easiest is what? P-series. So you could use a P-series on this, okay? And if this guy does what? Converges, and it's bigger, then what do you know that has to do? Converge, okay? So what do you know that's going to do? Converge, because it's even smaller. Now let's say that you wanted to show that something diverged. If something diverged, then what would the smaller thing have to do? Diverge. Okay? So let's see if I can think off the top of my head. We know what that does. I don't know, we'll get to some. You'll see, okay? Sorry, I can't think off the top of my head sometimes. Alright, so if you have something smaller that diverges, the bigger has to diverge. If you have something bigger that converges, then the smaller has to converge. So write that down in your own words somehow. Discuss it in your group how you want to say that. And you could write that down on your blue sheet in your notes. Okay? So when you're dealing with the direct comparison test, if the bigger, where am I at? If the bigger converges, so bigger converges, then the smaller has to converge. Okay? If the smaller diverges, then the bigger diverges. And I'm going to show you, it's easy to like think of it in a picture, and I know I have one in the notes, so something like this. So B sub n is something that is converging, right? Then what does this A sub n do? It says, I can't get past you, I'm stuck kind of thing, right? So it also has to converge, because it's like, oh, it's locking you down. It's holding you down like the man. Okay, so it also has to converge, okay? Does that kind of make sense? And you can think of it too, if you have this smaller A sub n going crazy, going all the way up, and B sub n's like, right, what does it have to do? It also has to go up. It also has to diverge, okay? All right, so let's look at this one. We want to use a direct comparison test to see if it's going to converge or diverge. So let's just first get some series and see if it works out. What's something that you could compare this to? Start with maybe leaving off that part. All right, so 1 over 3n squared, and this one is bigger or smaller? Huh? It's bigger because the denominator is smaller, right? All right, and then what's something else you could compare it with? You could leave that off. and you would just have 1 over n squared, right? And what do you know this one does? Converges by the p series, because your p here is 2. So what does it mean this guy has to do? If this one was bigger and converged, then this one also has to converge by the direct comparison test. So 2 test names you have to stick there. Yeah. We don't have what it converges to. The only one that we have what it converges to is the geometric and the telescopic. Okay? Good question. Even though an integral test, like the integral will show you a number, that doesn't mean the series converges to that either. That was for an integral. Okay. Yeah. Yes. No, you could go straight to here. I just kind of like show you how to break it down if you want the logical. So coefficients and constants don't matter. Huh? Coefficients and constants. You can just drop this. Well, you want to make sure you drop them appropriately. Okay. So that's why I kind of went from here to here and then here to here, so you could kind of see the logic. Okay? Because if I just drop the 2, right, then that's an easy comparison. And then if I just drop the 3, again, these two are an easy comparison. Is that? Yeah, but it's like, yeah, you could go from here to here if you can see it. Absolutely. This is definitely smaller. Okay, yes.
Are you able to factor out 1/3 out of the summation of 17?
Yeah, you are. Yeah, you can do this. Same thing. Okay. Alright. You guys try this next one in your group. Oh, sorry. Are they flip-flopped? Okay. So do the radical n cubed plus 1. Try that one. Talk about it in your group. Like, what are you comparing it to first off? Good. And what is that? Bigger or smaller? Bigger, right? Is that okay, Tyler? Is that okay? That's bigger? Okay. So Tyler, what does this guy do? Converge or diverge? Converges by what? P series. What if, okay, what if this diverged? Do you know anything about this one? No. Okay? So it'd be like saying, hey, this bigger guy diverges. Well, this guy's like, sweet, I could go this way or I could go this way. I've got lots of options, right? So we still don't know what a sub n would do. Okay? But this one worked out for us. It definitely converged by the p series. And it's bigger, so what does this guy do? Tyler, keep going for me. That's all you're going to say? Very good. Alright, do the next one. This right here, if this one diverged, then you're back to square one. You haven't shown anything. Try something else.
So,
Yeah.
and my son.
Okay. So in that particular case, it just
You add
was a wash.
so,
Does that make sense?
Yeah.
It's kind of like when we were doing the term test, and I had that one over n, and the limit was 0. Can you see anything? Nope. So you're back to square one again. Try something else. Good question. All right, Lane, what do you want to compare this to?
I did one over.
And what is this one, bigger or smaller? Smaller?
It's more small. Is it
So let's see, the denominator is
one greater?
bigger, which makes it smaller, right? I know, but then you were like, oh.
Well, then you would skip it.
Oh. Okay. Just second out. All right. All right, so you're good with that?
Yeah.
All right, so what does this guy do? Diverges by p series. That's a good thing. If it converged, we'd be back to square one. Okay, because this is the smaller, it diverged. So what does this guy do? Diverges by direct comparison test. And I don't care if you abbreviate your notes in your homework, but on the quizzes and tests, you better write it all out. No. What's comp? I don't know. No, seriously though. Write it all out, okay? Alright. Turning to this next one, which is the limit comparison test. And a limit comparison test says, hey, you get to pick any series you want, or sequence in this case if you're looking at it here, but any one that you want, pick anything you want, and take your original divided by the one you pick, okay, and take the limit of that ratio. If this limit is finite and positive, okay, then either these both converge or they both diverge.
When you say finite,
Finite means that you get a finite number.
positive.
Positive finite. Doesn't have to be whole.
So it can't be 0. It can't be 0.
Right, not be 0. 0 is not
Or
positive.
infinity.
Or infinity. Alright. So this is like a little hint that you can do a lot of times. So when you're going to pick your b sub n, one of the things you can do is try to disregard all but the highest powers of the numerator and denominator. So if I had n squared plus 2n plus 3 all over n cubed plus 2, what did I use 2 again? How about 4n? Okay? If I had something like this going on, well, I'm going to disregard all but the highest powers in the numerator and denominator. So the series I'm going to pick would be like n squared over n cubed, which is just what? 1 over n. And that's a really good one to compare it to, because what do you know this does? Diverges. What's the special name for that? Harmonic. Okay, series. So that diverges. All right, so then when I go and take that limit, we can see what happens. Is that okay? Or you just want to say, okay, let's actually get to a problem, right? All right, so let's look at this one. Disregard all but the highest powers, or in this case, like the growing stuff, so you have exponential growth. So which one do you want to compare it to? Do you have any n's going on in the numerator? So just do a 1. Do you have anything going on in the denominator? So let's pick it to be 3 to the n. And this is what we're going to take it and do that division by. So on this guy, what do you know happens? That's the same as what? See that? Is that a p series?
Not on
No, how can you set that up? You get 0, and that's a wash. No, you can't factor. Geometric, good. Because that's the same as what to the n? 1/3 to the n. So this would be geometric, and does this converge or diverge? Converge, right? Because that absolute value of r is less than 1. Alright, so this converges by geometric. So now let's actually go find what happens to this one. So you're going to take the limit, as n goes to infinity, of this guy divided by this guy. So 2 over 3 to the n minus 5 divided by, which is the same as multiplying by the reciprocal, so divided by or multiplying by 3 to the n over 1. Is that okay? So you divide as multiply by reciprocal. Okay? And what do you get out as you take that limit? So let me just rewrite it, see if this helps. That'd be 2 times 3 to the n over 3 to the n minus 5. Jacob, what do you think? Yes. Yay, Jacob! Bigger on top, bigger on bottom are the same, Jacob. Bigger on top, bigger on bottom are the same. The same. So you're going to take the coefficients of the same growing exponents. So this would give you 2. And hey, 2 is finite, and 2 is positive. So this one converged. So what do you know this guy has to do? Converge as well. So this one converges by the limit comparison test. Yes. So, talk in your group, see if anybody has questions over that before we do the next one.
That first part where we made it's that's a necessary thing, less than it determines if it's finite positive, which it is.
Right. So talk to your group. Tell your group any observations you see or any questions you see.
We do
So it's doesn't get it divergence. Then this would diverge. Yeah.
the only thing.
Anybody need more time on this discussion? I'm so glad Skylar just started this. That makes me happy. Oh, hold on. I skipped one, didn't I? Sorry. I don't know. I'll have to write. You guys are my rock stars. You're going to do amazing. Not even worried. A average on this test. And you know who's going to lead it for us? You guys are going to have the highest average. All right. So let's look at this one. Shane and Lindsay, I'm expecting A's. Nothing but an A on this. You can do it.
Like I said, I like chapter 1 of AP.
Chapter 1.
Make it like that.
I like chapter 1 of Algebra 1.
Hey, that was
Okay. Shane, I'm going to call on you now. I'm thinking of Shane. Yeah. Shane, what are you going to compare this one to?
1 over 3.
Yay!
distribute it on the bottom, you get cube, which is the highest power, and you discard it.
So I'm gonna pause you, but the highest degree isn't 1. The highest degree is 0 in the numerator. So that's
Oh,
okay. Sorry. It's
no,
okay.
it's okay.
You got the right idea. Okay. So what, Shane? What does this one do? Converges by what? All right. All right. So now what, Shane? Keep going for me. Okay.
Alright, we do 1 cube. Yeah, that.
Okay. The limit as what? Got it. You start with the original.
Oh, yeah, divided.
This divided by this. Okay. So 1 over. Oh, were you just gonna distribute? Is that what you're saying? N cubed plus. Okay, that's fine. Divided by. So you can make it times the reciprocal. N cubed over 1. And what do you get out? 1. 1 is finite. And 1 is positive. So this guy converged. So what does this guy have to do? Should I keep saying it? You get to finish this problem. Finish it out. What?
Converges by the limit comparison.
Yay, Shane! Alright. Whoa. I agree, this is lengthy. So the next one is all it bears. Alright. Anybody have any more questions before I move on?
Lindy and Jones.
Vice versa. Yeah, Shane does not get credit for that.
Alright, Lindy. We got this. What are we going to compare it to? Alright, and what can we simplify that to? Ethan! And what does this guy do? This one is the most popular one. What's this one called? Oh, the harmonic one. This is the harmonic series, so at HD, which diverges. And I don't care on this one if you say diverges because it's the harmonic series, or you say diverges because it's by P series. I'm fine either way. Okay? Yes. Okay. Diverges by P series, or because it's the harmonic series. Okay. Lindy, keep going. You got this, girl. Okay. Which equals 5, which is diverges by the. Yeah, clap for her. That was good. Great job. That was sweet. Woo-hoo!
No, super clap on 3.
Oh.
1, 2, 3. They always make you do this.
Alright, oh, here. That's all. You did it. Those are the 2 tests we're learning today.
Oh, yeah, it's just the whole day.
Oh, yeah. Yeah, exactly.
equal to?
0.
You can't.
1. Why? Okay, so let's start with
Because they accidentally told me that it's special.
in factorial. How could I rewrite that if I wanted to pull the first thing out? That'd be what? N times n minus 1 factorial. All right. Well, let's let n equal 1. Okay. So that would mean 1 factorial equals 1 times 1 minus 1 factorial, right? Okay. So what's 1 factorial?
0. 1.
1 equals 1 times 1 minus 1 would be 0 factorial. So look, 1 equals 0 factorial.
Is that true?
Yeah.
That's one
Law.
Oh.
No!
All right. So take a couple minutes if you want to now relook over your 8-2 stuff before you take your 8-2 quiz.
What's the problem with putting that up there? Because a minus b is 0 and you divide it by 0.